Okay, guys, what I want to do now is want to go over the last two that you need to know for your quiz on this eventually. We're going to have, like I said, we already did the first three on the previous Thursday. I sent out a little video on just a reminder of that. Pythagorean theorem, cones, and spheres. And today we're going to do similar triangles and then area of a triangle. Okay. And then I'm going to go through just like I did on the last video, I'm going to kind of go through the formula first, talk about the formula, how the formula works out, and then what we're going to do is we're going to do a question of each of them. Just a reminder, I think I told you that the order I'm doing them is kind of as they get more challenging. The first one, the formula was set, and you used that formula to get the answer. The second one, you had to modify the formula a little bit, but then you just took the derivative and put it in. The third one, we introduced the fact that there could be more than two variables in the question. What if there's three? And we, again, worked that out. And then the two today is, what if the formula isn't really so much a formula, but a ratio? And then the last one is, what if we did have one like the cone question where we did have the extra variable in it and we had to do a product rule. So basically we're going to do the two that we're going to do today. Why are they more challenging? One is the formula for the first question is not obvious because there isn't a formula, you kind of got to figure it out. That's the trick to the fourth one. And the fifth one, the formula is obvious, but the derivative is more complicated because there's a product rule. So again, each of the 5 questions kind of builds up in intensity in different directions. So it's not like going down the same road. Okay, first one, what if you have similar triangles? So I have a triangle up here. For the sake of discussion, I'm going to call this the little blue triangle and the big red triangle. Okay? So we got a little red triangle and we got a big triangle. Now, it doesn't actually have to be a right triangle, but it will be for the homework. Why did I say that? Because it kind of looks like x squared plus y squared is z squared, but that's not what's happening here, okay? What we want to do is we want to show that the ratios, use the ratios, or what we would call tangent in trigonometry. And there are 2 ways to actually address the question. You can think of it as the tangent is, relative to this angle here, is opposite over adjacent. Tangent is opposite over adjacent. So the tangent of the angle is the same. Then the red one ratio has to be equal to the blue ratio. So what we're going to say is that relative to this angle here, opposite over hypotenuse, opposite over adjacent has to equal opposite over adjacent. Now the ratio can also be done in geometry by saying that the corresponding sides of corresponding parts of triangles have to have equal ratios. So you could also say h1 divided by y has to equal h2 divided by x plus y. And then, now keep in mind, h1 and h2 will be numbers. Like, I'll tell you how high h1 is and how high h2 is. X and the y are the variables. It's kind of like an implicit differentiation question. So keep in mind when I do this, you have to think of like h and y as numbers like 7 or 2. So when you cross multiply, you're going to get an equation. Well, you're going to get an equation here. But remember, when you do implicit differentiation, you don't want to equals. Oh, crap. Sorry, guys. This would be h2. You guys, remember, this distance here is x plus y, so let's go with h2 times y. Now, because these are constants, kind of like we did earlier, like with the pi over 12 or the pi over 3 or whatever, when I take the derivative, the constant just sits there. Well, sorry, this is a y. 1 plus y prime. Oh, sorry, it's x prime. Plus y prime equals h1 y prime. So when you do the question here, it's always going to be that formula. Okay, it's just going to be the ratio there. So the second formula is the area of a triangle. So we're using similar triangles for number 4, and then the formula for number 5 is the area of a triangle. Now, I say this one for last. It's not actually super hard because it's kind of like the very first one, almost like we circle around. We're not going to adjust the formula at all, but the derivative does have this in there. So when I go to take the derivative of this, so area, let me put a little dotted line here, dot, 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 is 1/2 base times height. Remember, when you take the derivative of this, and this is where students sometimes forget, you know, what we learned earlier in 2.3, is first times the derivative of the second plus the second times the derivative of the first. So this one is because there's no real formula, it's just similar triangles that can, it will not be as ugly looking when we actually do it because there'll be numbers here. Okay. The number 5, the derivative is a little more complicated because you're doing a product rule on that. Okay, so let's look at a question on this. First question. This is for number 4. A street light is mounted atop a 13-foot pole. A boy 4 feet tall is walking away from the base of the pole at 2 feet per second. So I normally use different colors, but I don't think those colors, when I start using colors, they don't seem to show up so good on the board. So you're going to have to just get used to using one color here, monochrome, black and white. Okay, so you got a light here, and you got a boy walking away from the light, and the boy makes a shadow. And there are 2 questions, and they seem like the same question. At least they did to me when I was a kid. I gotta tell you, this question, I love this question because I have memories of this question as a kid. And I'll tell you about that when we get there, okay? So the question is, how fast is the tip of that shadow growing? And we all probably remember this as a kid, when you're a little kid. When you're walking underneath the streetlight, you start noticing that as you move, your shadow's growing back and forth, right? So it's kind of weird. Like when you're right underneath the shadow and you start to walk, your shadow starts to grow. That's kind of cool. So and you know, obviously you get too far away, you can't see the shadow anymore. But we all experience that, you know. The point being that if the boy is walking this way, 2 feet per second, notice that the shadow is going to be much longer than it was at this point in time. So we know the shadow is growing, okay? So now, what we're going to do is go back to what we already established now. Let's look at what we did here. Notice I told you before that we're going to give you the height of the boy and the height of the light. So when I go to use the formula here, I know the height of the boy is 4 and the height of the light in the air is 13. Now, so I know this is 13 and this is 4. And then here's the distance from the wall, and here's the shadow. So for the sake of discussion here, x is the distance, not from the wall, from the base of the shadow, and y is the shadow's length. Sorry, the distance from the base of the pole. So we know this is going to be y divided by x plus y. So when I do all the cross multiplying now, I get 4x plus 4y equals 13y. Now, notice something kind of interesting. I'm not going to actually take the derivative the same. I distributed that h1 in. Now, let's collect our like terms. 4x equals 9y. Now, this derivative is so easy, people panic and think they did it wrong. What's the derivative of x? It's the derivative of x. What's the derivative of y? It's the derivative of y. No, it's not 1 because we're doing implicit differentiation. The thing that's changing is time, right? We're in feet per second. So the thing that's counting off is 1 second, 2 seconds, 3 seconds as the boy walks. So the time is the actual thing that's changing in our lives. That's the variable in our lives. And so what we're going to say is this is 4x prime equals 9y prime. So notice the equation is ridiculously easy. It's the easiest of all 5 equations, but it wasn't given to us. So we had to arrive at the equation. 4 distances equals 9 shadows at all times. As the person's walking, 4 times the distance from the wall is always going to be equal to 9 times the length of the person's shadow. And that's not a formula. That's something we had to actually figure out by using sum or triangle. So the beauty of 4, in a weird way, is it's the only one that doesn't have a formula to it, which is not the beautiful part. The beautiful part is when you're done, you get 4x equals 9y. And it's just dependent on the ratio that shows up there. Now, the key to this question, and this is the practical part of the being a word problem, we're looking for the shadow's speed. So I'm looking for y prime. Y prime is the thing I'm looking for. What I know is how fast the person's walking. Oh, that's the derivative of x. If x is the distance, the rate which they're leaving the wall is the rate of change of the wall. The distance from that, I keep saying wall, the pole is going to be 2. So that makes this 8. So y prime is 8 ninths. And the units, remember, I'm not going to penalize you for units, okay? I'm not going to penalize you for units. So don't worry about it, but if we were taking the test at school, I'd give you an extra credit point for the units, but I haven't really figured out how I'm going to do that yet, so I may or may not be giving the extra credit on this one, because I may be testing in a different way. Feet per second. Okay, now, here's the thing. The reason I remember this in school is this wasn't the when I was in college, this wasn't the question. When I had this question, actually I was a senior in high school, and I remember distinctly I got the question, I got 8 ninths. Okay, I got 8 ninths. And then I went and looked in the back, because back in the day, that's how you looked up your answers. They had the answers in the back of the textbook. I don't know if you guys use textbooks anymore, but when I looked in the back of the textbook, it said 26 ninths. And I thought, what the heck? What did I do wrong? So I did the question over again, and I got 8 ninths. And I remember, because I was in college, I was in high school at the time, I was taking the class at UCSB, and I had never gone to professor's office hours before. So I was scared, but I knew I was doing the math right. And so I said, what the heck? How come the tip is not 8 ninths? That's just what I found. And he said the same thing that I kind of did here. I said, no, I went to the professor and he said, no, you didn't do that, Peters. You found the rate at which the shadow is growing. And I said, well, that's how fast the tip is moving. He said, no, it's not. If you're in physics, you might get this already. But here's the thing, the shadow is growing. But the shadow's attached to the boy, right? But the boy is moving, right? So it's kind of like being on a bus, and you're going down the bus at 50 miles an hour. Brum, 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 brum. If you're going down the bus at 50 miles an hour and you get up and walk at 2 miles an hour, you're actually moving at 52 miles an hour relative to the ground, right? Because you get the 50 for the bus, and you're on the bus, it's moving. It's kind of like when you watch people on escalators kind of walking fast. They seem like they're walking really fast, right? So remember, the tip of the shadow, see, I told you, this green just isn't going to cut it, is it? The tip of the shadow is not only the shadow speed, but the boy's speed. You got to add the two together. So, and remember, this will be the question on the test, okay? And I think the homework as well. But I broke it up into 2 questions because I know I myself got stuck. I got 8 ninths and I thought I was done. And then, yes, the shadow is 8 ninths, but the boy is 2. So 8 ninths plus 18 ninths is 26 ninths. So the answer to this question is 8 ninths, and this one is 26 ninths. Now, it's still feet per second. It's still feet per second. And again, don't worry about the units. We're gonna kind of call off the units right now. Okay, so that is an example of the number 4 on your homework. And it'll be question number 13 on your homework. Question 13 will be the person walking away, and you have to find out how fast the tip of the shadow is moving. So, and then now let's look at the other one here. Now, the first 4 we did have some physical applications to them. You know, you got the ball growing, you got the water going in the tank, you got the plane flying away, you got the shadow growing. This one, there is a good real world one to use, but it uses Boyle's law, PV equals nRT, which I might give you a homework question because mathematicians are kind of silly. What they do is they hold temperature constant. They say the temperature never changes, so they say PV equals C, and it's a little bit of an easier question. But and you'll have one like that later. But the one that's on your test is the magic triangle. Okay, there's this triangle that's growing. Okay, and you want to keep in mind that this is of the 5 has the least practical applications. But what it does do is it introduces the idea of using the product rule. We know the area of a triangle. 1/2 base times height, and we know how to take its derivative. 1/2 b times h prime plus h times 1/2 b prime. And only because we just did it earlier today. Like I remember the first time I didn't know what to do. Like, I got 2 variables. And again, kind of back to my own high school experience of being in calculus is, but when someone showed me how to do it, this is called a product. And when you have a product, you use the product rule. And of course, when someone said that, then all of a sudden it's there. Now, the trick, of course, is now can you put all the numbers in the right place? Oh man, see, I keep putting this down trying to use a different color. I can't. I use this thing color. So read the question. The height is increasing at a rate. Remember how we read this? The height's derivative is 2. So that's got to be 2. The base of the triangle is increasing at a rate of 3. So that must mean this is 3. So h prime is 2 and the base is 3. At what rate is the area growing? Okay, so we want, that's b prime. We want to find, this is the $64,000 question. We want to know a prime. When the area is 36, it appears like we don't need that. It appears like we don't need that because there's no a in the question. Well, let's just write that down for the sake of discussion. And the base is 6. So the base is 6. You go 1/2 times 6 times, so 1/2 times 6 times 2. Oh, crap. Where's h? What's h? Oh, okay, I have to figure, this is kind of like the Pythagorean theorem question all over again. We have to make sure we find h. How are we going to find h? We're going to put it back in the formula. Kind of like when we had x and the y, we had to find z, or we had the x and the z, we had to find y. We used the Pythagorean theorem. Here, we have the formula. Area is 1/2 base times height, and so if we know the area is 36, 1/2 times 6 times 3, or no, times h, so you get 3h, so h is 12. So one of the things about this question is you're going to have to also realize that I'm going to give you the base or the height, and you got to figure out the other one. But I'll give you the area, so that'll all work out, okay? So what do I end up with here? A prime is 6 plus 18, which is 24, okay? And what are the units? The units are a little touchy on this one. The rates, our heights and bases are in centimeters, but area is in centimeters squared. The time unit is the same. Remember, the derivative is time. The derivative is seconds here. So we get 24 seconds. So this will be, I want to say question 19 on your homework. So this is question, I think, 19 on your homework, and I think this is question 13 on your homework. 6 is the sphere question. 11, I think, yeah, actually, I don't know. Okay, but anyways, I got all 5 of them, but they don't appear that way in the homework is a better way to say that. So just remember, you're gonna have a triangle question, you're gonna have an implicit differentiation question, then you're also gonna have the sphere question, you're gonna have the Pythagorean theorem question, and you're gonna have, what was the last one? Sphere, Pythagorean theorem, and, the volume question. So I think the order goes like this. I think the sphere question is number 6. I think the sphere question is number 6. Number 13, sphere question is number 6. The Pythagorean theorem question is 11. 13, it's hard doing this from memory. I should probably just look in the book, right? 13 is the shadow question. 19 is the area of triangle question. 27 is the cone question. So 6 is the sphere question. 11 is the Pythagorean theorem question. 13 is the shadow question. Number 19 is the area of the triangle question, and number 27 is the volume question. Just so you know which one goes with which. Okay?